I'm going to go step by step through Lab 17 with you because it can be a little challenging to understand exactly what they're looking for. So we're going to go through it step by step. Okay, so please make sure that you're following the procedure in the book for Lab 17 exactly, because that will help you, first of all. Okay, then for this purposes, this orange one up here is going to be hydrogen. Okay, black is carbon, red is oxygen, and blue is nitrogen. And I'll color these in just a little bit so that you can kind of see the colors that I'm talking about. Okay, the one other thing, I'm going to use silver to show, I'm going to use a silver to show the chemical bonds between the atoms within a molecule. Okay, so basically in Lab 17 you are creating models of different molecules, and you're using these guys right here. So you're using, this is your hydrogen atom, and you can see it only, these are called bonding sites. So the little sticks that come out are the places on that atom where it can create a chemical bond to another atom. So hydrogen can only create one chemical bond to another atom. That's really important to notice. Okay? Then you're going to see oxygen, for example. Oxygen has two bonding sites, which means that it can chemically bond either to two different atoms or to one different atom two times. Okay, and then nitrogen, same thing. It has three bonding sites, so it can either combine to three different atoms, one at each point, or maybe two different atoms, one at one point and one at two of the others, or in three different places, okay, to the same other atom. It depends. Okay, and carbon has four bonding sites. Now, as these are right now, these are all very unstable atoms, and that's because in order for them to be stable, all of their bonding sites, which represents missing electrons on their electron rings, you'll get into that in high school, but just in case you were wondering, okay, or you'd heard it before, okay, each of these bonding sites that's open, okay, means that it needs to bond to another atom, otherwise it's not stable and it could be very reactive. So in order to create stable molecules, all of the bonding sites must be bonded chemically to another atom. So basically what your task is here is to use these four atoms, okay, and then you're using these little sticks as the chemical bonds to represent the chemical bonds to create stable atoms. It's very, very important. Okay. So, part A, we'll go through really quickly, okay? Part A, it says build a model of a molecule of water with two hydrogens and one oxygen, okay? So I'm going to kind of go through this with you. So you have two hydrogens and one oxygen. Now you're going to need to obviously put the chemical bonds on them together. Now I'm going to do number one with you. Okay, so you know exactly what to write in your notebooks. And I expect this to be done either on a piece of paper, which is easier, or you're welcome to do it in your iPads later. Okay, so I bonded two hydrogens to my one oxygen, and here are my chemical bonds. Okay, so in your notebook, it should look like this. Okay, we just did number one. Okay, and we did... And you're going to draw the molecule exactly as it looks. So in the center was the oxygen. Okay, and then it had the hydrogen here and a hydrogen here. And they were chemically bonded together. Okay, but you can't just draw the molecule, you also need to write the chemical formula. How do you know the chemical formula? Well, how many hydrogens does it have? It has two, so I'm going to write H, which is the chemical symbol for hydrogen, and then I'm going to write 2, because that tells me that there are two hydrogens. And there's one oxygen, so I just write O. Okay, and that's the chemical formula for H2O, or water. Okay, so that's what I expect you to have written for every single molecule that you create. Okay, now I'm going to go through with you right now how to create these molecules. I'm not going to do any of the rest of them with you, but listen very carefully because some of the directions are confusing. Okay, so when you get to question 5, it's going to ask you to build a couple more molecules. Okay, so you are going to make a model of carbon, and you're going to use one carbon and see how many different hydrogens you can get onto this carbon. Okay, remember how many bonding sites there are and how many bonding sites you have of hydrogen. Okay, so you're basically going to connect it like this. So here's your carbon. You're going to connect it to as many hydrogen as you can until it is a stable molecule. That means that there are no empty bonding sites left. Okay? Then you're going to draw that molecule. Then you're going to do the same thing with nitrogen. Okay? You're going to use one nitrogen and put as many hydrogen atoms as you can, bond as many hydrogens to this nitrogen as you can, okay, and make sure that it is a stable molecule. That means all the bonding sites, okay, must be bonded to other atoms. It may not be solo, okay? All right, so that's 2 molecules in number 5, okay? So you have to then draw both of the molecule diagrams and write the chemical formulas for both of them, okay? So for number 5, you're going to have 2 different molecules to write about here. Okay? Then you're going to go to number 6, and you're going to create, in number 6, you're going to create a molecule using just 2 oxygen atoms. Okay? That's it. Create a molecule using just 2 oxygen atoms. What do you need to do in order to connect these and create it with just these 2? Okay, and that's number 6. So you'll also have a molecule diagram and a chemical formula for number 6. Then you're going to go to number 7. Number 7, you are going to have, again, 2 different molecules that you're going to draw. The first molecule that you're going to draw, okay, you're going to construct a molecule using 2 hydrogen atoms. 2 hydrogen atoms, okay, pretty straightforward. Then you're going to draw the molecule, put the chemical formula. Then your second one is going to be using 2 nitrogen atoms. So using 2 nitrogen atoms, okay, and only 2 nitrogen atoms, create 1 molecule. Okay, you're not using hydrogen, you're not using carbon or oxygen, just 2 nitrogen. And for those, then, put the molecule diagram and the chemical formula. Okay, then you guys are going to get a little bit of freedom. Okay, Part B. Part B is awesome because you guys will get to create kind of your own molecules and come up with your own chemical formulas. Okay, so it says construct and draw at least 4 more molecules. Okay, 4 molecules more. And this is number 11. So number 11, you have 1, 2, 3, 4 molecules that you need to do for number 11. Okay, so for number 1, you just have this 1, right? For number 6, you just have 1. But for number 11, you have 4 different molecules. Now, the stipulation here is that each molecule has to have at least 2 atoms, but it can't have any more than 5. So 2, 3, 4, 5, that's all you can have of atoms. So I don't want you to make the largest molecule with all the atoms that you possibly can, because that's not yet. Okay, you can have between 2 and 5, and all the bonding sites, again, must be connected to another atom, which means that all the bonding sites, it has to be a stable molecule. It can't have just this random bonding site, okay, sticking out. It needs to be connected. They all need to be bonded to another atom. Okay? Now, after you do number 11, you'll move on to number 12. And number 12, okay, asks you to draw 2 more molecules, but this time you only have 1 rule. Now this is where you get to have kind of some fun with it, is you can use as many atoms as you want, but the rule that you have to follow is that it has to be a stable molecule. So all of the bonding sites, okay, all of the bonding sites must be connected to another atom. Okay, so you can make it as big as you want or can, but you cannot have any leftover bonding sites. They all have to be connected to an atom. Okay, so only stipulation. You do 2 like that, and again, you draw the molecule out. Now, if you make it too big, it's going to be really complicated to draw that molecule and to do the chemical formula, but you can do it. Just make sure that you do it. Okay. Then the last one that you have to do is for carbon dioxide, which is CO2, and that's number 15. So number 15 is your last one that you have to do. Okay, you're going to do the chemical formula for CO2, which is carbon dioxide. Okay, then go ahead and you can complete I believe you're completing the analysis questions in your folders or in your Pages documents. Okay, so hopefully that helps. I know it's kind of a confusing lab the way that they describe it, but it's fun. So enjoy it and good luck.